Hi everyone. In this video, I want to talk to you about some of the places where scientific knowledge is found. Where can you and others read or learn about science? The main place that scientists learn about science, the main way that scientists communicate new results to one another, is in scientific journals. Scientific journals are a specialized kind of publication that scientists use. They've been around since the 17th century. Some of the first scientific journals were created by the Royal Society in Great Britain. Scientific journals are sort of like a magazine, but instead of articles written by journalists, scientists themselves write up descriptions of the results of their studies and experiments. They write about new theories, and they're mostly for the consumption of other scientists. Since about the mid-20th century, most journals are peer-reviewed. What peer-reviewed means is that if, let's say, I, as a scientist, do an experiment in my lab, and then I decide I want to communicate the results of this experiment to other scientists, I'll send it to the journal. An editor at the journal, who's another scientist, will read it and then send it out to somewhere between 1, 3, sometimes as many as 5 other scientists. They'll read it, they'll decide if the work was done well, if it was described well, if the theory is sound, and they'll make a judgment about whether or not to publish it. So peer review is this process where scientific publications involve scientists weighing in on the quality of the work. Traditionally, this has been interpreted to mean that if you see something in a scientific journal, it's of high quality, although people sometimes challenge that and suggest that peer review is kind of a rough filter. It catches some of the bigger mistakes some of the time, but something getting into a journal, even a very prestigious or famous journal, is not a guarantee that it's high quality. Now, there's a few things to know about scientific journals. As you move forward, let's say you're a psychology major or you're in another scientific field, you're going to be reading articles in scientific journals. What's some context you should know about these? Well, one is that the journals themselves vary a lot. Every scientific field has its own specialty journals. There are a few journals that cover a broad range of sciences. Some of the journals are considered very prestigious. They're very selective. It's hard to get into, some less so. Some journals cover a really big breadth. There's one journal that's just called Science, and what they publish is science, anything from any area of science. They're considered one of the more prestigious ones. There's another very prestigious one called Nature. Prestige does not always correspond to quality, however. That's something you should keep in mind. Sometimes things get into those journals because they're flashy or exciting, not necessarily because they're the most sound work. Journals also vary a lot in their editorial processes and their policies. So some journals, for example, try to be selective and try to say, we only want to publish the most exciting new findings. Other journals try to be comprehensive and they say, we want to publish anything that's of good enough quality, regardless of whether we think it's exciting or high impact. We just want the record to be complete. Finally, journals vary a lot in their access policies. So in the traditional model of publishing, it was kind of like an old magazine where you had to have a subscription. They would mail you a print journal. During the electronic era, this got transitioned into electronic subscriptions. University libraries often subscribe to these journals. Sometimes they pay a ridiculously large amount of money. And so a new innovation in scientific publishing has been what are called open access journals, which are journals that anybody can go and read. You don't have to be a subscriber to pay to read them. They're funded in a few different ways. Sometimes the scientists pay money to be published in them. Sometimes they're funded by public funds, especially in Europe. The government funds some of these kinds of journals. Now, as I said earlier, this idea of peer review is best thought of as a rough filter, not a guarantee of quality. You have 1, 2, 3 other scientists looking at the work. They may catch stuff, but they may not. Historically, peer review has been a closed process. What this means is that if I'm a scientist, I send something to the journal, the editor looks at it, the reviewers look at it, they make a decision. If it doesn't get published, nobody ever knows. If it does get published, nobody sees the inside workings of that process, what the journal's editor and what the reviewers said along the way. This is slowly starting to change. And so a lot of scientists now are arguing that we need to have more open peer review so that everybody sees the entirety of the process. People should see things that were rejected as well as accepted so they know what's considered not good enough, or if the journal made mistakes. People should see how the editorial process shapes the final product. There's also been a growth of what's known as post-publication peer review, meaning that this idea of peer review shouldn't and doesn't have to end when something is published. Other scientists who weren't part of the review process can read the article, they can comment. Some journals, some electronic journals have comments right in the journal itself, but there are also other places online where scientists will post comments about published articles. So this idea that the scientific community engages in an ongoing critical evaluation of work doesn't have to end when the journal article is published. Journal articles are a major way that scientists advance their careers. And so something you should be aware of is that there was probably some kind of stakes there for the scientist getting this published. This is a good thing in the sense that it incentivizes scientists to be productive, to produce work. It's also been argued that this can sometimes distort the incentives for scientists to try to make things look more exciting and more clean. So there's this push-pull, this back and forth between insistence on transparency so that the readers and reviewers can see everything, and this desire by scientists to publish their work. Finally, one criticism that's been historically raised about journals is that many journals favor positive, sort of something that says we made a new discovery, rather than a quote-unquote negative finding that says we tried something but it didn't work out. And one of the arguments that's been made is this produces a distorted record, that we don't know what are the dead ends in science, what are the attempts. We don't know when something was published but then somebody else couldn't replicate it and it turned out to be a false alarm. And so there's been a lot of movement in recent years towards trying to get journals to publish null results, results that show no evidence for an effect, to have a balanced scientific record. Now, another place you will find science is in the media, in the news media, in places like, traditional publications that are high-quality science journalism outlets like Scientific American or The Atlantic. BuzzFeed is a newer, somewhat newer online outlet that has a quite good science reporting group. Some of these media outlets, like the ones I just named, have science sections staffed by specialists in science journalism. So these are journalists who specialize in writing about science. They often have some kind of scientific training. They know how science works and how to cover it. Other places you'll read about science in the media have more generalist reporters. They might get assigned one day to do a science article, another day to do an arts and entertainment article, and they may not be specialists in science. The quality of media coverage of science varies enormously. There are some amazing science writers out there who are doing really terrific work in bringing science to the public. There are some awful outlets out there that are just trying to get clicks and sell advertisements, and there's a whole spectrum in between. So you should be aware as a consumer in the media that you need to critically evaluate what you're reading. Sometimes it's garbage, sometimes it's terrific. Part of this process to be aware of is to know where these articles come from. So one very common way that these articles get started is that a scientist working through their university or working through the journal publisher or working through a professional organization will put out a press release. So they'll say, we did this study, we got this result, it's being published in one of these journals that are just for specialists, but we think it's worth the public knowing about. So we're going to put out a press release. We're going to tell the media about our work and see if they want to cover it. So this is one of the main channels from a specialty scientific journal to a general audience publication like a news outlet or a media site. Sometimes scientists also write directly for the media. There are some websites now like The Conversation where you can go read scientists speaking directly to the public rather than through a journalist. When you're reading science journalism, as I said, the quality varies hugely, and so there are a few things you should look for. One, is there a link to the journal article? If you read something and there's not even a link where you could possibly check to see, is the way this is being described accurate, you should at least be a little bit suspicious. Now, sometimes they leave out the link or whatever. It doesn't automatically mean it's not good, but it's usually a good sign if they're saying, yeah, here's our description for the general public, and you can click through for the details if you want to see it. Another thing to ask yourself, is the media coverage just repeating the scientists' claims, or is it evaluating them skeptically? So these press releases that I mentioned, they're put out by the scientists saying, hey, everybody cover this work. A good science journalist will read that, will think about it, and then will go talk to other scientists who weren't involved in the work. And they'll go say to them, hey, there's this new study. They put out a press release, or I heard about it in some other way. What do you think about it? And the article will quote other experts saying, yes, it's good, or it has these limitations, or whatever. So that's something to look for as well, is the journalists themselves showing signs of being skeptical and critical and talking to other people who could be that way. Finally, something else to know about is that science, as you'll learn in this class, single studies are almost never definitive. They're usually a little piece of the puzzle on the way to having some broader understanding. And so if you read an article that's just about one study, or a few of them maybe, you should probably have a little bit of, believe the work in the sense that they really did this, they really meant to do it sincerely, but it's not highly certain, it's not the final word, this is part of the process. Whereas sometimes you'll read science journalism where a journalist will interview a whole bunch of experts, look across a lot of studies. Those are often a little bit more trustworthy in the sense of being closer to a final answer. Single studies rarely give strong support for everything. It's the accumulation of evidence across multiple lines of inquiry that gives us a broader sense of what science is telling us. And of course, when you see things, and we're going to talk about this in this class, how do you evaluate the claims in the headlines and the articles? Are they actually supported by the research? So sometimes journalists will go a little too far in describing a study to try to make it seem exciting. Sometimes the scientists themselves will do that, and the journalists will repeat that. And so you have to be careful and say, is the research actually supporting what they're saying? Now, in addition to journals and media sites, there are a few other places in the science communication ecosystem to know about. Conferences are usually in-person meetings. Nowadays, a lot of them are taking place over Zoom. They're meetings where scientists present results and discuss them with other scientists. These are often preliminary results, especially in psychology. Conferences are not considered final word. They're a place where people talk about in-progress work. Preprints are a new thing in psychology. They've been around in some other fields. These are places where scientists can put up articles about their own work that don't go through a journal process. Oftentimes, scientists will put a draft or the initial submission that they're planning to submit to a journal. So these are places where you can read the latest science. In addition, oftentimes scientists, after something is published, will put it on a preprint server. The reason for that, as I mentioned, traditionally, you have to have a subscription to the journal. If a scientist puts their own copy on a preprint server, then that means it's open to the public. You don't have to have a subscription. So preprint servers can be a really great place to have access to science, getting around these sort of paywalls that journals try to make money off of. There are various online repositories for the intermediate products in science or for ancillary materials. Open Science Framework is one that a lot of psychologists use. And so it might have the raw data, the computer code, things like that. Often these are mostly of interest to other specialists, but sometimes if you just want to see, hey, they described this experiment, what did the stimuli look like? You might be able to go find that online. As I mentioned, there are these websites like PubPeer where scientists can post critiques and commentary and discussion about articles. And then finally, scientists themselves, as well as journalists, as well as lots of other people, are using new media, social media like Twitter or Snapchat, blogs, podcasts as ways to communicate sometimes with each other. I have a podcast called The Black Goat. It's mostly for other psychologists, although if you want to check it out, go ahead. You might find it interesting, you might not. Sometimes scientists use these media to communicate with each other. Sometimes they use them to go directly to the public around journalists. I want to come back to this idea I started with a journal article and talk about how it fits into this ecosystem. The traditional view of a journal article is that it was kind of a standalone piece of information about an experiment or a couple of experiments or something like that. You read it, you know what you're supposed to know. Nowadays, in the electronic era, with online repositories, with media coverage, with press releases, all those kinds of things, it probably makes more sense to think of a journal article as kind of a node in a network, that it's connected sometimes explicitly through links in the article. Sometimes you just have to know about this stuff, about all this other information. And so if you really want to understand a study as a whole, there might be a lot of information out there. Sometimes it's well organized, sometimes you have to go looking for it, but there's a lot available to you to try to better understand science, critically read it, evaluate it, and reach your own conclusions. Thanks everybody for listening. Be sure and do the concept check. I'll see you next time.